Hey, this is Unit 1, Matter, Part 0. This is sort of just an introduction to the periodic table. What we would do on the first day of school. This is stuff you technically should know from middle school. You probably don't remember it. So we're just going to kind of quick review of exactly what the periodic table can tell us. For instance, the periodic table can tell you the names of all the elements. We will talk more about exactly what an element is on a different day, but for now, it tells you the names of the elements. Periodic table can also tell you the symbols of all the elements. These are special abbreviations. Each element has its own abbreviation. The periodic table can also tell you a lot of other things, and we're going to spend this entire year talking about those one by one. Yay. Let's try a few. I want you to look at a periodic table and find the symbols for these elements. Try all of these A through I. I want you to actually pause the video, find all the symbols, and then after you've found all the symbols, press play. Okay, did you find all the symbols? Let's check it. Carbon is just a C, calcium is Ca, chlorine is C, and that is a lowercase l. That is not an I, it's a lowercase l. That's important. I see that as a problem all year coming up, so please just keep an eye on it. That is a lowercase l, not a capital I. Cesium is Cs, chromium Cr, cadmium Cd, cerium Ce, californium Cf. Yes, it is named after California. And cobalt Co. You may notice that all of these above elements that we've just written in have different symbols. All of these elements start with the letter C, but we found different ways to abbreviate them so that each element could have its own symbol. This way, if I say the element Ca, you know there's only one possible element that I could be talking about when I say Ca. So which element is that again? That's calcium. Ca is calcium. Ca is not carbon, even though carbon also starts with Ca. Ca is not californium, even though californium also starts with Ca. Ca can only ever be calcium. You may have noticed that some of those above elements have symbols that make sense based on the spellings of their names. All of those elements start with the letter C, and if the symbol has a second letter, that letter is also somewhere in the spelling of this element's name. So like californium wasn't discovered until much, much later after calcium was discovered. So Ca was already taken from calcium. So when we went to make a symbol for californium, we couldn't do Ca, that was already calcium. So we picked a different letter. We couldn't do Cl, that was already chlorine, but we could do Cf for californium, just like that. And you can see that like similarly, you can see it with cesium as Cs and chromium Cr. We used like the spellings to figure out what that second letter was going to be. But not every element symbol is an abbreviation of its name that makes sense. For instance, if you look at element number 29 on the periodic table, element number 29 is copper, and its symbol is Cu. Wait a minute. Copper does not have a letter U in it. Why is its symbol Cu? Well, some element symbols are based on the spelling of the element's name in different languages. So like in Latin, copper is called cuprous, and copper is one of the oldest elements that people found. So it got a name real early. So in Latin, back when people spoke Latin, basically, the symbol Cu still makes sense because it's Cu for cuprous, because that was the Latin word for it. So now there are quite a few other elements on the periodic table that have symbols that don't match their names in English, and it's time for a scavenger hunt. You're going to tell me, well, you're not going to literally tell me because this is a video, but see how many you can find. See if you can find all of them. You need to, down here, make a list of all the elements you can find that have symbols that don't match the way their names are spelled, like how copper was Cu. Pause the video and go ahead and do that. Pause the video. Okay. Let's take a look. So I'm going to put these in no particular order. This is just the order I think of them. But there's sodium, which is Na. If you have one written down, check it off as I write it. There's potassium, which is K. There's iron, which is Fe. Potassium, sodium, iron, these symbols all came from Latin for these particular elements. Gold, Au, that also comes from Latin. Silver, Ag, that one actually I think comes from both Latin and Spanish. It's like argentum or something like that. Tin is Sn, that's from Latin. It's stannus. Iron was ferrous. Gold is like aurum, A-U-R-U-M, something like that. I don't know. Tungsten actually comes from German. The symbol for tungsten is a W because in German, the word for tungsten is Wolfram. Wolfram in a German accent, probably. Antimony, SB. If I'm being totally honest, I have no idea where that SB came from. I've never bothered to Google it. Mercury, Hg, that's another one that's from Latin. And then lead, Pb, that's actually plumbus, Pb. Like plumbing, it's actually the same root word because pipes used to be made out of lead before we realized that gives you cancer. So there are actually a couple more you might be able to find if you're using a most updated periodic table that has the newest 8 or so elements on there. But the periodic tables that we're using were given to us by the state of Texas and are about 15 years old. So they're not that updated. But it's fine. That it's not a big deal. They're all so radioactive. We don't know what they do anyway. Anyway, let's look at the next page. What do you notice that all of these element symbols have in common? Well, all of those symbols started with a capital letter. That's not how you spell capital. There we go. And what differences do you notice? Well, I notice that some of the element symbols are different because if there is a second letter, which they don't all have, only some symbols have a second letter at all, but if it does have a second letter, it is lowercase. Let's talk about elements and compounds. Compounds are combinations of multiple elements. We abbreviate the combinations of elements together into one compound formula. So here are some examples. An element can be like H2, He, Li, Be, Bc, N2, O2, F2, Ne, Na, Mg. That's hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. For compounds, they look a little different. H2O, that's water. LiOH, that's called lithium hydroxide. CO2, carbon dioxide. This is called magnesium nitrate. This is hydrofluoric acid. This is called methane or carbon tetrahydride. This is silicon monoxide, calcium carbonate, and sulfur trioxide. By the end of the semester, you'll actually know how to name all but one of those, the acids we won't get to until the spring. But you'll know eventually how to give all of these compounds their chemical names, but we're not there yet. That's not till December. So let's talk about what we can say for these differences between elements and compounds right now. What is the difference between an element and a compound? How do you know? From looking at an abbreviation, if you're looking at an element, like just one, or if you're looking at a compound. Well, all of the element symbols are different from the compound formulas, because an element symbol has only one capital letter. While a compound formula always has two or more capital letters. There may be lowercase letters or there may not be in any given element or any given compound, but you will always know by counting the capital letters if it's an element or if it's a compound. One capital letter is always an element. More than one capital letter, always a compound. If you're looking at an abbreviation, you'll know it's an element symbol because there's only one capital letter. Even if there's a second letter, even if there's those tiny little numbers at the bottom, these things are called subscripts. It can still be an element with those numbers. It can still be an element with the second letter. But there will only be one capital letter. That's how you'll know it's an element. And for a compound formula, instead, it will have two or more capital letters. Again, for a compound formula, it's possible for there to be no subscripts, like this HF here has no subscripts. It can also have subscripts, like CH4. It can have no lowercase letters, like CO2 here is all capitals. Or there might be some lowercase letters, like calcium carbonate has some lowercase letters. Those things, subscripts, lowercase letters, either being present or absent for both lowercase letters and for subscripts, that will not change if it's an element or a compound. The only way you can tell if it's an element or a compound is to check the capital letters specifically. And that also means when you're writing it, you need to be careful to write with a capital letter for the first letter every single time. Some people have handwriting where it kind of looks the same, capital and lowercase. Like I've seen people write cobalt's symbol as CO like this, but that's actually not cobalt. It's only cobalt if the lowercase, if the O is lowercase. Because if you write C and a capital O that's the same size as the C, that's actually carbon monoxide, which is a compound. So you have to be careful how you write, and you got to just kind of watch your handwriting. So something to look out for. This is the end of the notes. You'll see there's a page here of practice problems. So you can practice identifying if something's an element or a compound. But as far as this video goes, I'm done. It's nice to meet you.